This is problem number 5 from section 3.3. In this problem it says find the derivative of the function, and they give you y equals 4x minus 5 divided by x squared plus 3x. Notice that we have a fraction error or a division. We're going to have to use a new rule here, which is similar to the product rule that we used in the last video. This is going to be the quotient rule. So it's similar because it's still a combination of the top function and the bottom function taking the derivatives, but this one's really important because of the subtraction sign. You have to make sure that you have this formula down, because if you accidentally flop the u prime and v and the v prime and u in the formula, you're going to not get the correct derivative. So it's important to know this quotient rule. The product rule, you can kind of you don't really even need to remember the rule. You just need to take the derivative of one of the functions and multiply it times the original of the other, and vice versa, and you're okay. But here you have to know the formula. So let's go ahead and find the derivative of the function. I always start these problems out by saying u is the top function, v is the bottom function. So we're going to have u equals 4x minus 5, u prime, v is x squared plus 3x, and then v prime. So I can do the derivative of the top, which is just 4, right? Because this is the power comes to the front. Subtract 1, that goes away. Derivative constant, 0. I can do the derivative of the bottom, which is 2x to the first, I don't need to write it, plus 3, this will be x to the 0, which is just 3. So I took the derivative of each of these, and now I use the quotient rule. So u prime is 4 times v, which is x squared plus 3x, minus v prime, which v prime is 2x plus 3, times u, which is 4x minus 5. All over, this will be v squared, which is x squared plus 3x squared. And remember, this is dy over dx equal to, right, derivative of y with respect to x. The bottom, I never really, I always keep it in this, if you want to call it a simplified version. It's not an expanded version. I never really expand the bottom. There's not too many advantages of it. Occasionally it'll happen, but most of the time I'm looking to cancel out an x squared plus 3x if I can after I distribute the top terms. So let's go ahead and see what happens. So this is going to be 4x squared plus 12x minus 2x times 4x is 8x squared. 2x times negative 5 is negative 10x. 3 times 4x is 12x minus 15. All over x squared plus 3x squared. That's going to equal, let's distribute the negative, so I end up with 4x squared plus 12x minus 8x squared plus 10x minus 12x plus 15. All over x squared plus 3x squared. Combine some terms together. This is negative 4x squared. 12x and negative 12x, they cancel. And then I'm left with 10x here, and then we kind of cross them out here, plus 15, all over x squared plus 3x squared. Now at this point, I could try to factor this quadratic, but whatever I get for factorizations from this quadratic It's probably not going to cancel down here because this is x squared plus 3x, which, you're going to get two binomials with the highest power being 1. This has a highest power of 2. It's not going to cancel out. So this is the derivative, the simplified version of it.